Greetings to everyone. I'm Ilamati from 2nd MSc Mathematics. I'm doing my project under the guidance of Dr. V. Balaji, Associate Professor, PG and Research Department of Mathematics, Sagrada College, Tirupattur. My topic is admin labeling in 8-star graph. Definitions. A graph G is an ordered triple G equal to V of G, A of G, rho of G, where V of G equal to non-empty set of vertices, E of G equal to set of H, row of G mapping defined on the unordered pair of the vertices. Star graph. A star graph GK is defined as a graph which single vertices connected by all vertices where the degree of single vertex is k minus 1 and degree other vertices is degree 1. Mean graph. A graph with p vertices and q edges is said to be an mean graph if there exists a function from a vertices of set g equal to 1, 0, 1, 2, 3, etc. q such that the induced map from the edge set of g equal to 1 to q is defined by equal to u of v, g of u plus g of v divided 2 if g of u plus g of v is odd, g of u plus g of v plus 1 divided 2 g of u plus g of v is odd. Consequently, all edges needs distinct labels from the set 1, 2, 3, etc. q. Odd mean labeling. A graph G equal to V comma G E with P vertices and Q edges is said to be an odd mean graph if there exists a function V of G tends to 0, 1, 2, 3, etc. to Q minus 1 such that the induced map E of G 1, 3, 5, etc. to Q minus 1 is defined by equal to U of V, G of U plus G of V divided 2 if G of U plus G of V is even, G of U plus G of V plus 1 divided 2, G of U plus G of V is odd. Consequently, all H's receive distinct labels from the set 1, 3, 5, etc. 2q minus 1. Wedge. A wedge is defined as a edge connecting two components of a graph denoted wedge symbol. Omega of g of omega wedge less than omega of g. Notation G equal to k1 comma m wedge k1 comma n is the two-star graph connected by a wedge. Odd-mean labeling in 8-star graph theorem. The 8-star graph G equal to k1 comma pi e1, k1 comma pi e2, which k1 comma pi e3, which k1 comma pi e4, k1 comma pi e5, k1 comma pi e6, k1 comma pi e7, k1 comma pi e8, k1 if is an odd-mean graph if and only if modulus pi e7 minus pi e8 less than or equal to pi e1 plus pi e2 plus pi e3 plus pi e4 plus pi e5 plus pi e6 plus pi e7 plus pi e8 plus 9. Proof Rn G equal to k1 comma pi e1 which k1 comma pi e2 which k1 comma pi e3 which k1 comma pi e4 which k1 comma pi e5 which k1 comma pi e6 which k1 comma pi e7 which k1 comma pi e8 such that pi e7 less than or equal to pi e8, pi e1 less than or equal to pi e2 less than or equal to pi e3 less than or equal to pi e4 less than or equal to pi e5 less than or equal to pi e7 less than or equal to pi e8 is it existing case if part assume that pi e7 less than or equal to pi e8 less than or equal to pi e1 plus pi e2 plus pi e3 plus pi e4 plus pi e5 plus pi e6 plus 9. Case 1, pi e8 equal to pi e1 plus pi e2 plus pi e3 4 plus pi e5 plus pi e6 plus pi e7 plus pi 9. Consider the graph G equal to k1 comma pi e1 plus wedge k1 comma pi e2 wedge k1 comma pi e3 wedge k1 comma pi e3 wedge k1 comma pi e4 wedge k1 comma pi e5 wedge k1 comma pi e6 wedge let k1 comma pi e7 wedge pi e1 plus pi e2 plus pi e3 plus pi e4 plus pi e5 plus pi e6 plus 9. Let L union L row 1 less than or equal to row less than or equal to pi e1 union m sigma 1 less than or equal to sigma 1 less than or equal to pi e2 union n delta 1 less than or equal to delta less than or equal to pi e3 union O union O neta 1 less than or equal to neta less than or equal to pi e4 union P psi 1 less than or equal to psi pi e 5 union Q lambda 1 less than or equal to lambda pi E6 union R union R tau 1 less than or equal to tau pi E8 E7 union S union S zeta 1 less than or equal to zeta less than or equal to pi E8 be the vertex set of G. Then G equal to K1 comma pi E1 K1 comma pi E2 K1 comma pi E3 which K1 comma pi E4 which K1 comma pi E5 which K1 comma pi E6 which K1 comma pi E7 which K1 comma pi E dash pi E1 plus pi E2 plus pi E3 plus pi E4 plus pi E5 plus pi E6 plus pi E7 plus pi E8 plus 8 vertexes and pi e1 plus pi e2 plus pi e3 plus pi e4 plus pi e5 plus pi e6 plus pi e7 plus pi e8 plus 7 edges. The need vertex labeling SE V of G 0 1 2 Q minus 1 is to be defined as the follows. SE of S equal to 2Q minus 2 SE of 2Q minus 1 SEL 1 SEL of M 2 pi E1 plus pi E2 plus 4 SE of N pi 2 pi E1 plus 2 pi E2 plus 1 SE of O pi E1 plus pi E2 plus pi E3 plus 2 SE of P pi 4 pi E1 plus 2 pi E2 plus pi E3 plus 2 SE of Q 4 pi E1 plus 4 pi E2 plus 4 pi E3 plus 4 pi E4 SE of R 4 pi E1 plus 4 pi E2 plus 4 pi E4 plus 4 pi E4 plus 1 SE of L row equal to 4 row 1 less than or equal to row less than or equal to pi E1 SE of M sigma 4 sigma plus 2 1 less than or equal to sigma less than or equal to pi E2 SE of N delta 4 less pi E1 plus 4 delta plus pi E2 plus 3 1 less than or equal to delta less than or equal to pi E3 SE of 4 neta 4 pi E1 plus 4 neta plus 2 1 less than or equal to pi E4 SE of pi xi 4 less than or equal 4 pi E1 plus 4 xi plus 4 pi E1 plus 4 pi E3 1 less than or equal to xi less than or equal to pi E5 1 less SE of q lambda 4 pi E1 plus 4 4 lambda 4 pi E2 plus 2 1 less than or equal to pi E6 similarly we can prove this similarly we can prove this all the cases existing case are 40 cases then non-existing case are 40 cases are existing cases then non-existing case we shall assume g equal to pi 1 comma pi e1 which way 1 comma pi e2 which k 1 comma pi e3 which k 1 comma pi e4 we can consider the condition. This is the existing non-existing graph. Let us consider the component k1 comma 17 of AG. Each the every vertexes must be labeled is as distinct which needs to get distinct odd edge. We must have 17 edges odd edge label for the component k1 comma 17 of G. Moreover, all possible of the induced edge when SE of zeta 61 is the set 61 59 57 55 51 49 47 45 43 41 39 37 35 33 31 which implies there are only 16 possible odd edge labels but the component k1 comma 17 has 17 edges. Therefore we conclude the 7 k1 comma 1 which k1 comma 17 not be an odd-bin graph SE of SE zeta equal to 61. Similarly, we can prove all non-existing cases. Application of the odd-bin graph. Odd-bin graph and odd-bin labeling have developed into very useful mathematic tools from simulating and resolving practical issues is structured network system. Networks structured are originally created in agriculture sector. Modeling analysis agriculture system integration, flow management, soft monitoring and server placement, prop distribution, field connecting admin label. Case studies and practical implementation from Form A and Form B. Future research directions. These are the applications for admin labeling. Conclusion: in this study, we have developed into the intricate nature of admin labeling within 8-star graph of finding reveal the 8-star graph g equal to k1 comma pi e1 which k1 comma pi e2 which k1 comma pi e3 which k1 comma pi e4 which k1 comma pi e5 which k1 comma pi e6 which k1 comma pi e7 which k1 comma pi e8 qualifies as a Hardman graph if and only if conditions modulus pi e7 which minus pi e8 less than or equal to pi e1 plus pi e2 plus pi e3 plus pi e4 plus pi e5 plus pi e6 plus 9 holds that true. This relation not only exceeds the understanding of admin graph but also provide a significant creation of for ensuring distinct edges labels within the graph structure. Bibliography. Thank you.